Hi, welcome to Technology for Noob. Today I would be sharing my learnings on Tensorflow using Python as a programming language and by doing an exercise on linear regression. So before I start about all the things which I just said, I would just like to make few things clear. So there are already a lot of videos and articles already written on TensorFlow, so I don't need to add a lot. But what I feel when people try to switch to TensorFlow, the major idea is to learn about deep learning or neural networks or artificial intelligence. And exactly, you are on the right path. There is so much noise of TensorFlow nowadays. Everybody is excited to learn it and everybody wants to get the most from the current technology. So the people who are coming from a statistics background and people who have already worked on machine learning, for them the learning TensorFlow can be a very easy task. But let's say you are not much familiar with all this thing and you are much more comfortable on using some third-party vendors API for training any model, and you don't know much about the nitty-gritty of the algorithms, then the challenges can come. So that's the whole motivation of mine to take this session or the tutorial. So starting with, so TensorFlow is nothing but a framework. It's not a module, it's not a library, it's not what we think. It's a framework. And framework to do what? It's a framework to train neural networks, to create neural networks, to create deep learning architecture, to create AI applications, whatever you want to do. So make it clear that TensorFlow is not a library, it's not a module, it's a framework. And what it has been used for, so earlier Google used to do and all those things already in the internet, so I won't be taking much time there. So this is about TensorFlow, and now let's come on the I am going to use Python. So for the Python I am going to use my Anaconda. So for that I am activating my not required, I can directly go on. So what I'm doing is simply I am calling my virtual environment where I have installed Python 3.6 already, and I'm going to use Jupyter Notebook as my uh, console kind of. I mean, it's not console, it's a browser based code code writing application. So I'm launching my notebook. So till then, let's start with the basics. So what I'm gonna do with TensorFlow is, first I'm going to introduce with the basics of the TensorFlow, but at the end I'm going to take up the exercise of linear regression for our learning purpose. So before that, I'm just going to use a simple Excel and explain how linear regression works actually, and then we can go ahead from there. So I have taken one. I'm just going to do some on. So let's try to understand linear regression first. On linear regression, so everybody would have already heard about, there are few conditions which we need to meet before doing any linear regression, before applying any linear regression algorithm. So I'm just going to go through over it, but not on those very bookish word, but I'm just going to be very practical how we actually do linear regression. So first we need the independent variables and one dependent variable. So that is going to be my y variable. So these are the first two things. The second thing is all the rows are independent from each other and very specific. Now let's start how actually we solve the linear regression problem. So we have some x, we have some y. So here I am just going to type x, here we have some y, and let's say I have some value, let's say I just simply have 1 2 as my x variable. You can take x as age and y can be salary or whatever, it does not matter a lot. And I'm just going to give some random number here, 5,50. So just to make sure I get what I'm trying to communicate. So now these are my x variable, this is my y variable. So now I need to apply linear regression. So what linear regression is? It's very simple. We are trying to fit a linear equation on our data. This is the whole thing here. So what we do, we try to fit we try to fit a linear equation on our data and then we say, okay, this is what the equation looks like. So very standard equation of line is what we need. So y equal to some weight into my x variables plus some bias values. This is a very simple line equation, y is equal to mx plus c, and this is what we actually do. But there are few things that will come, so let's try to apply. So for getting this particular equation to be applied, we need that equation here. So my y would be some value and my bias would be some value, it's some constant, and my formula would be w. So let's say for now my w is -5 and my bias is 10, and here I am predicting a output. Let's assume we have this as some equation which we have got from some model. So now y is equal to w f4. This is what I am predicting now by taking this as my model values, into 1 plus my bias, and that's it. This is what I predicted and this is what the actual value was, and so now this is how we get the values. Or just to make it clear, so this is good. Now what we do in our linear regression algorithm, we get these values, then we try to update this 5 and 10 so that our error would be less. So what the error is, so most of the time, every time we use sum of squares as the error value, error calculation. So what we do is sum of squares, so y, or you can do anyway, and either way, y prediction minus y actual, or however you want, but at the end we are going to square, so it does not matter. And this is what the total error, and what I am gonna do is sum of square error. So this is my loss function here. So the loss function is simple, sum of squares of errors. That's what the loss function is. I would just type it here. My loss function is sum of predicted minus actual square, symbol. And now my whole objective is to get some weights which help me on reducing my loss. So as you can see, I am able to reduce our loss value by changing something, but this is not. So this is what the linear regression actually this is what happens inside the linear regression objects. Now let's try to do the same thing in our Tensorflow, and that's the whole idea. I chose the linear regression as our problem statement. Let's get familiar with linear regression. Tensorflow. So getting familiar to Tensorflow is simple. We are already in Python. And I have already imported Tensorflow. If you have not or downloaded or installed, just go here. There is a whole bunch of tutorial already available in Tensorflow's website directly, and if you can go here install, you will get all the help on the installation. If you go on develop, you get a brief get starting with TensorFlow. I'm following a lot from this particular part, but then I'm adding what I learned and how I understood the TensorFlow and every other stuff easily. So I have already covered the linear regression. So let's start with TensorFlow. So I'm importing TensorFlow. This is how you do in Python. TensorFlow as TF. TF is some alias name which I'm giving. So once if this runs successfully, it means I have TensorFlow already in my environment. Import TensorFlow as TF. I would be very quick on explaining the basics because you can follow it from this tutorial as well, but just to narrate and to speed up things. So in TensorFlow, this is how we do, but like we learn any programming language, we can learn this framework as well. So in any programming language, the core components are always how to define a constant, how to define a variable, how to call some function. So all those things are there, and they are very much similar to Python already. It's just a little changes. And there is one thing which we need to learn, which we need to understand is we are talking about a framework which is going to do a lot on neural networks or artificial intelligence. What does it mean is then we have to come on the terminology of the neural networks and the structures through which neural networks have been solved. So in our plain vanilla programming language like C, Python and whatever, we do define something like list, dictionaries and all. So here in TensorFlow or in neural networks, there is a concept of tensor. So these tensors are the basic building blocks for any neural network, and this is how we start with our TensorFlow as well. So let me define a tensor in our TensorFlow. So don't go on calling it as a tensor, but you can call. I'm defining a constant in TensorFlow. So here in Python I can define my constant like this, but in TensorFlow I need to do something different. TF dot constant. I need to tell to the framework, okay, I'm defining a as a constant, and this is how it will understand. I can't say okay a is equal to 5 and I can't pass it to my network. So how I need to do is a is equal to t.5 constant and some value. Simple. And if you type a, you see it does not type the value 3, but it says okay it is some tensor which is a constant and it has a data type of float 32. So how can I see my value now? So it's very simple. Again, coming to the framework language or terminology, anything which has been trained on TensorFlow can only be viewed by a session. So tf dot session, so this you need to have up and running every time. So session ses dot run, and what I want to see is a. So now you can see, and at the back end if you see it says but these are the available on your machine and could speed up GPU CPU computations, blah blah things. So just look at it. When you are learning you will get a lot. So this is how you define a constant variable, and similarly you have different things where like tf dot placeholder. So what's the benefit of a placeholder is like, let me just type it. So okay, so to define we need another library, numpy dot float 32, and similarly, so what a placeholder is, kind of just assume it as an empty place, and you have said okay keep a space of float 32 for me. I will get some value there and I will do the computation later. This is what you do. And when we define some variable, so there is a very specific keyword for that. You can define a variable, and while defining a variable you need to be you have to define a some value to start with, -3 let's say here, and saying d type is equal to np dot float again. Oh, something np dot float 32. So now I have defined my variable as well. So these are the few things to start with. Now let's do some operation as well. So you can pause here and go back and redo whatever I said, but just to keep it more crisp, let's say I have two variables here, right? I mean, I have one constant here, so let me use this one only, a, and then let's say I have b also, and if I want a plus b, I mean it would add, but it does not show the value again, as again I need to be on sash.run a plus b, and then only I will be able to do the addition operation. So just remember again, Tensorflow is a framework where your whatever operation you do, you define it one time, and then when you do sash.run only, then only you would be able to get the output, or you would see the output. Okay, so let's start with our basic exercise, which was the main focus, doing a linear regression. So just to start with, I would just do few more things. I would just share few more things. So let's say I need to do some calculation. Same, let's go on the same formula, y is equal to weight into x plus b. So this is my equation which I want to calculate. So how I would do it in Tensorflow? So it's very simple. The things which we learned just now, constant, variable and placeholder, we are going to use the same. So first we need to define for w, it is going to be a variable. This is what we are going to update. You remember from here, this is what we are going to update. So w would always be tf dot variable, and I can say start with 3 or any number, and d type is equal to np dot float 32. Similarly, I need to define my b, which can be again any value, it does not matter. So this is how I have defined my weight and my bias value. Now x is going to be my placeholder. Why? Because this is where I would pass my all the x values. Similarly, y values I have, I will pass again. So x value is going to be my placeholder, tf dot placeholder, and its d type is equal to np dot float 32. So this is fine. Similarly, I would just say for actual y value, so I would just say actual y placeholder, fine. Now what we need to do is we need to define our linear model. So my linear model is going to be w into x plus b. I hope this is clear. So my linear equation is going to be w weight into my x variable and my b. And similarly here what we did, we calculated the errors. So the errors, the way to calculate error is we need to subtract these two value. So one is predicted, one is actual, and then we have to square. So for this particular task, there is already a function available in Tensorflow that is called tf dot reduce sum. So what it will do, if you read out here, computes the sum of elements across dimension of a tensor. But which element? So what we need to do is, we have this predicted values when we pass the x value there, and then we have the actual values which we already know in our data. So I am just going to do this here, and this is going to be my loss function. Once I have defined my loss function, what I need to do is I need to create a training algorithm which changes my weights accordingly. So for that, very universal gradient descent algorithm is there. The main idea of gradient descent is it calculates the error first, then it tries to shift the w based on the descent, I mean the gradient value, and then it updates the w accordingly. And how it updates is very simple. I won't be covering a lot on gradient descent, but the way it calculates the new w dash would be very simple. W plus we are going to adjust descent, so my learning rate into my d, my cost d of my cost function. It's a partial derivation and of d based on w, and similarly it will update the bias value similarly by this equation, b minus learning rate into same partial differentiation of my cost function based on only by b. I mean, this is how it is. You can go and read it a lot, but we would focus more here. So to do that, there is one thing which we need to do is, now we need to train this entire thing using our gradient descent. So what we need to do is very simple. We have to define a training function which take my loss and do the computation. So let's say this is my train object, tf dot train dot gradient descent optimizer, and we have to pass a learning rate. As you can see here, we need to pass a learning rate. I am just giving some random number here, 0.01, and then this train thing needs to do what? So you can see here, train needs to I should have called it optimizer train, and my optimizer train dot, now if you can see there is a minimize, so I need to minimize my loss function. So this is going to be my main point where it will take loss function and it will check, okay, what is loss? I need to reduce it by putting values on linear model and actual wise. My linear model will say, okay, this is what the equation is. I need to change my weights based on this function or this algorithm. I need to change the weight and bias. So this is the whole structure of defining a linear equation, a linear regression in TensorFlow. Now how to train? Same again. I'm going to do a mistake, but I wanted to do that. Says.run, I need to pass my train object, and now I need to pass my values. But what values? We have never talked about the values. So let's say I have few ideas. A is equal to 1, 2, 3, 4, and similarly my b's are my y, so a is my x, so 2, 4, 6, 8. So a is my x, the independent variable, b is my dependent variable, and now I'm going to pass it. But what we need to pass is, for our entire function train, if I go train loss linear model and actual y, so this is where actual y came, so actual y is my b. When we go on our linear model, we get x, so x is going to be my a, and that's it. Says.run, okay, got it. So we got this error, and I know we don't need to look at it. What has happened when, if you remember on the initial time, when I defined a constant, I was able to run it directly. When I defined a placeholder, I was able to run it, but I didn't do the addition using a placeholder. So we missed that part. So there, the whole idea is, as I have explained earlier, TensorFlow works you define all the calculation first and then you run it directly on the session. Here we have also defined placeholder, we have defined variable. So to do that, we need to initialize those values pre-hand before running the run command on session. So how to do that is, we need to initialize, so I am calling it as a function tf dot global variables initializer. So it will initialize everything. Then what I need to do is sys run, and I would just call this init, and it will initialize my values. And then if I go on and call this function, it runs successfully. Now if I need to check what is my updated w and b, I can just simply say comma b. Just a minute. Sys.run w train a and b. So I need to read the error. Argument to int must be string or tensor, cannot convert int into. Okay, let me check it again. So we defined our x, y, linear model, and then we are reducing the sum. Okay, directly. Okay, here there is one thing which I missed here. In our exercise in Excel, I needed to square first and then do the sum, right? So what I'm missing here is very simple thing, squared errors. And how to do that is tf dot square of our same thing, and our reduce loss function would be to reduce the sum of our squared error. And let's check whether it's running or not. Okay, w, where is my linear model? Here. Let me just check one more time. Train a b. So instead if I just say loss, it says, yeah, so it's doing the calculation, we are not wrong here. So the loss is getting calculated. Now I need to check the updated values. Sys.run, and so my weight is coming. What about b? Why b is not coming? It's okay. If my weight is coming, can I get it separately? For b it is not coming correctly. Oh, got it. So I have defined my b as a list, and I have also used b here as my bias. So I need to do, I would just change the name. So b, let's say I would just rename it b underscore 1, initializer this one, and now this is good, this is also good. Oh, how can I do give this one? So now I can get the values. If I run it again, where it is train, yeah, here I can get the new updated values. So this is a very simple example of linear regression, but we have not done much here. Let's go to the next step, where I would take a real-time data and I will solve the real-time problem using the same approach. I would just keep few things here from the previous one. I would just import pandas. It's a very helpful function for any data scientist or data scientist aspirant. So pandas spd, I believe this is enough for us for now. We don't need all of this. We need our data. So which data I'm going to use today is the simple auto mpg standard data set, which you can get it from UCI repository as well. So data is equal to pd dot read underscore CSV. I read my data. Let's check the data. So now I'm going to do a multivariate analysis using linear regression, and as you can see, this is how my data is. So this is my y variable, this is one variable which I'm gonna take, and the next variable which I'm gonna take. So making it a multivariate analysis, we need to, so what would be my new function? Y is equal to w1 into x1 plus w2 into x2 plus bias, right? This would be my new linear regression. So what I need to do is I need to get my values accordingly. I need w1, I need w2, then I need one bias, then I also need another x value, x1 let's say, and that's it. So this all are the things which are required. I need to update my equation w1x plus w2 into x1 plus b. So this is how my equation looks like. Same squared error would still be there, loss function would still be there, my optimizer would still be there, my train function loss will still be there. And this time I'm not gonna use this dummy thing. Now let's go and get our values here. So as you remember, last time I have given input as a uh, list to my tensor. So what I'm going to do is I'm going to prepare my one variable. I'm going to call it variable 1, which is going to be data displacement. And if you look at the value variable 1, it is a series. So because I can see the index, so values, and now it is in array, so I need to do it in list, 2.list. So this is how I got my first variable ready. I would just give the same name to it. Similarly, we need the second variable. What I'm gonna do is in horsepower, I will take the horsepower, I will use it here, variable 1, I would just call it variable 2, and similarly we need our third value, that is our target variable here. So I would just take it here and I would just call it target, and I would just take here I need to just say mpg, right? So as you can see now I have my all the values ready. Let's do, I'm not doing any EDA and all those stuff. We can do it offline as well. If you understand the crisp, then that's the main important thing here. So what I need to do is I need to pass my variables now x, x1 and actual, right? So here, coming here, I have x, that is var underscore 1, then I have x, what I have x1 and x2, x1, x2 is x2 is var underscore 2, and actual is my target. And shall I run it now? Let's see. So SAS is not defined. Okay, got it. I have missed one thing. Start the session, tf dot session. I will rerun it just to be sure. We read the data, we created all the variables, then this is what our equation looks like, or it is right. Then on our linear model, squared error, calculated the loss, optimizer, then I created the train function, then initialized the values, and then I ran x2 is not defined. Okay, x and x1, x and x1, done. Okay, good. Could not convert string to float. So what does it mean? Let's check. Do we have any missing values or not? That's the importance of doing a EDA beforehand. So I would just easily check whether we have any missing values or not. We don't have any missing values. Data mpg 0, so it isn't. What we are doing, cannot convert string to float. Act y, do we have act y or not? Yes, we do have act y. X variable 1, x 1 variable 2, act y, could not convert string to float. So it's still not there. Okay, let me just check one more thing. D type. Okay, so this is where object. Okay, got it. So this horsepower is an object, it's not an int already here. So what I'm gonna do, okay, let's switch to the weight as a new variable, and you can add any variable you want. So I'm going to restart, and let's do it one more time. This is how we learn. Linear regression, my variable 2 is now weights. There was no missing values, we know, hope so it's gonna run this time, and it did. Now I want to check what are the updated values here. What is my overall loss value? So I would just run it. This is so huge. And then I also want to know my I would just remove it, says dot run, what are my updated weights. So w comma w1 w2 comma b. So these are very huge numbers, as you can see. This is and just one more thing, in linear regression we are hoping that there is a linear relation between the x and y. So this was the first iteration. So what I mean when I said first iteration is I change it to one value, I see the crop. So but this is not the whole purpose of doing this thing. Now let's get familiar. I mean, what we need to do is we need to do this step n number of times. So what I'm gonna do, for I in range, I'm going to do the same process for 1000 times. What I'm gonna do, I'm going to train my model for 1000 times, and I would like to check the loss every time, that what's the loss that's coming. So print loss, and yeah, this would do. So as you can see, it's already went to infinity already, right? So what's the problem? So the main thing which we need to learn here is the learning rate. This matters a lot. So what I'm gonna do, I'm going to reduce it again. This is way less, so I hope this is gonna work, or I would just start it from here again. This time the values again started from infinity. Okay, that's not a problem. Can I reduce it even more? And I would just restart the kernel. So there are a whole lot of things comes when we come into the neural network. We do not get this idea when we use any API like sklearn or anything. So now here we have a little lesser values, and let's see. So now you can see the values are decreasing on each iteration. And for this one, just to give an idea, we had around 398 rows only, and the values are decreasing way lesser than expected. Let's check it again. And it's not learning at all. I need to increase it. So I'm getting the idea from looking at the loss values, right? If my loss value is changing, I'm on the right direction, and also it should be decreasing. This is what the whole idea of doing the whole exercise, right? So it's decreasing, but it's not decreasing a lot, which is fine. what extra I can do or to solve this thing is very simple. What I need to do is I need to just normalize my data here. The reason, if you remember, for linear regression, it's also one of the criteria that your data should be normalized. What I'm going to do is I'm going to normalize my variable 1. To do that, I can use my sklearn from sklearn package, sklearn import pre-processing. Just a minute. Pre-processing, and on the pre-processing I'm just gonna do on let me just load it again, the data. Pre-processing, I am going to I would just call it LV is equal to pre-processing dot min-max scaling. This will do, and this is my first value which I want to do, right? And similarly I have another variable that is weight. I will call it LB2. I will run it. If you check now, LB is, so mean value is gone by based on min max, and I mean you can read it out. I will just do one thing here. I won't remove where 1 is equal to LB. Perfect. And where underscore 2 is LB2. Same error will come here, right? So now we are done. Let's check what's the value we get now. And now the same, let's change the learning rate. So now it is decreasing, right? Yeah, we got it. We learned it now. So look, this is how I usually try to learn things, by getting my basics in place and I try to apply it on the new thing, whatever I am trying to learn. So now you see my error, my loss value is getting lesser by each iteration, and so do, if you can see, this is what the neural network actually requires. It requires a lot of iteration, but just to make sure, again we are expecting there is a linear trend between my x and y, which might not be there. So just be careful on all these notes. I hope you got what I wanted to communicate, and have fun. Thank you. Good day.